Fraction 7-2, day 1, dividing monomials. Essential question, how do you divide monomials? So this lesson will be all about dividing. We have 3 different vocab in this lesson. So we have quotient of powers, power of a quotient, and 0 exponent property. So first, quotient of powers. Looks like this. So this will be your shortcut for one of the shortcuts for this lesson. So if you have a to the m over a to the p, you are now going to subtract your exponents when you are simplifying. So in 7-1, we added and multiplied our exponents. Now we are subtracting them. Power of a quotient means that if we have a over b to the m is going to get distributed to both the a and the b, just like in 7-1. So we'd have a to the m over b to the m. The 0 exponent property says that if we raise anything to the power of 0, we are always going to get 1. So anything raised to the power of 0, no matter what, the answer is always 1. All right, here we go. Just like 7-1, we are going to write it out and do the shortcut for all of the problems. There are 8 problems in this lesson. All right. So now we've got a big fraction. Where on the top, I'm going to write out x to the 7th, so 7 times 1, 2, 3. And I've got y to the 5th, where I'm going to write out y 5 times. On the bottom, I have x to the 6th. And I've got y to the 3rd. The way you simplify monomials that you are dividing is by canceling when you have the same letter on the top and the bottom. So cancel, 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 cancel. I don't have any more x's on the bottom, so I have to leave the 1 on the top. Now I can go to my y's. Cancel, cancel, and cancel. So what I am left with is an x on the top and then 2 y's on the top. So that would be x, y squared. If I have nothing left on the bottom, I can just put a 1. So really xy squared is my answer. If there's nothing left on the bottom, put a 1, which really what you got for the top is your solution. If I am doing the shortcut, I am going to subtract my exponents. So I have x to the 7 minus 6, and then I have y to the 5 minus 3, so that will give me x to the 1st and y to the 2nd. All right, for the second one, this time I have negative 8 over 16. Right away, before I do anything, I am going to simplify this fraction. Remember, it's not negative 2 because the 8 is over the 16. We have to think about what can go into both 8 and 16. Well, 8 can go into it. So if I divide the top and the bottom by 8, I'm going to get negative 1 over 2. So negative 8 over 16 is the same as negative 1 over 2. Then I will expand. So 5/8. Or sorry, 5 x's, 8 y's, and 2 z's. On the bottom, I have 3 x's, 2 y's, and 1 z. You'll notice I'm kind of lining up my variables. If you want to do that, if it helps you, you can. So now when I simplify, I still keep it as -1 over 2. Cancel your x's, so I'm left with 2 x's on the top. Cancel my y's. I'm left with 1, 2, 3, 4, 5, 6 y's. And I am left with 1 z on the top. If I am doing the shortcut, I'm still simplifying to make -1 over 2. I am going to subtract my x's, so I have 5 minus 3. I'm going to subtract my y's, so I have 8 minus 2. And I'm going to subtract my z's, which is 2 minus 1. So that will give me -1 over 2 x squared, y to the 6th, z to the 1st power. In this lesson, we are only going to end up with positive exponents after we subtract. Therefore, they will all end up on the top of our fraction. In 7-2 day 2, we will end up with negative exponents when we subtract, and I will teach you that later. All right, now since we have an outside exponent, we know from 7-1 that we have to distribute that outside exponent to everything inside of our parentheses. So I will have 4 to the 3rd power, which is going to give me 64. Oh, actually, before I do that, I'm going to write this 3 times. I forgot about that. Okay, so then that means I'm going to take all these 4s, 4 times 4 times 4, so that'll give me 64. I have 3 C's, 3 C's, 3 C's, so that's 9 C's. I have 2, 4, 6 D's. And then if I do 5 times 5 times 5, I will get 125. Because I don't have any variables that can cancel, I don't have to expand my C's and D's. I do have to think about whether or not I can simplify 64 over 125, which I can't, so I am finished. So my answer is 64, C to the 9th, D to the 6th, over 125. If I am doing the shortcut, I am distributing my 3, which is what I already started doing the first time around. So I would have 4 to the 3rd on the top, over C to the 3 times 3, and D to the 2 times 3, over 5 to the 3rd. So that would give me 64, C to the 9th, D to the 6th, over 125. So the same thing. All right, one more like that. This time my outside exponent is 2. So I'm going to write my parenthesis twice. -3x y to the 3rd over 2x to the 4th y. Okay. So then I'm just going to take, I'm going to do -3 times -3, which is 9. I have 1, 2 x's on the top row. I have 3, 6 y's. On the bottom, 2 times 2 is 4. 4, 8 x's, and 1, 2 y's. You guys will notice that I'm not writing out every single one anymore, but if you still need to, that's just 1x, there's 3 y's, 4 x's, and 1 y. And then you could do the same thing for the other one. So if you visually need to see that written out and count it, you can still do that. Since I can simplify this more, I can expand. So I've got 9, 2 x's, 6 y's, over 4, 8 x's, and 2 y's. So when I'm done, I end up with 1, 2, 3, 4, 5, 6 x's on the bottom, and 1, 2, 3, 4 y's on the top. Now, since this is one that you are going to end up with negative exponents, I am actually not going to do the shortcut on this one. So the way that I would know if I got negative exponents is if I distributed the 2 to everything. You can see that I'm going to have more x's on the bottom than I would have on the top, because I'm going to have x squared on the top, x to the 8th on the bottom. So I'm going to leave it as just the written out way for today. Your homework won't have any with negative exponents, so you don't have to worry about what to do with that until the next lesson. All right. This one is going to look complicated, but it is actually very, very easy, and that is because of the outside exponent being a 0. If the entire parenthesis is raised to the 0 power, and I look back at my vocab, remember that anything raised to the power of 0 is just 1. So if my entire problem is raised to the power of 0, my answer is just 1. So no matter what, write it out or shortcut, I don't have to do anything. I'm automatically just going to get 1. When you have an individual variable with an exponent of 0, so this one is n to the 0, n to the 3rd, over n squared, all I'm going to do is just get rid of it. Completely ignore it. It's not even worth writing it. Forget it's there. Then on this one, I'll expand. So 3 n's on the top, 2 on the bottom. And I'm just left with n over 1, which is the same as n. If I wanted to do the shortcut, all I would have to do is subtract my exponents, and I would get n to the 1st, or just n. You do not need to write the 1, but you can if you want to. All right, last two. Negative 3xy to the 4th over 7x squared y to the 6th. This one also has an outside exponent of 0, so all our answer is 1. I always end up with people who try to solve problems like that where the answer is just 1. So don't be the person that does all the work to simplify that when really all you should have written was 1. So be careful. And our last one, x to the 0, y to the 4th, z to the 7th, over x squared y to the 0, z to the 5th. So my first step, I see some 0 exponents, so I'm just going to completely get rid of those. 4 y's, 7 z's, 2 x's, and 5 z's. Now you'll notice none of our y's even, or x's even cancel, so really I didn't even have to expand those. So it'll stay y to the fourth with an x squared on the bottom. All I have to do is cancel the z's. So I'm left with one z on the top. If I am doing a shortcut, my y to the fourth and my x squared can't be simplified, but then I could do z to the 7 minus 5, which will give me the z squared. All right, and our summary. To divide monomials, we're going to say expand and cancel, which is the write it out version. Or subtract the exponents of like variables, meaning the same.